Hi guys. Okay, so I'm going to begin our very first camming video on how to actually run the CNC and set up a toolpath. So I'm going to make a really simple little project, which is the candle holder, and then we'll set up a toolpath, and then we'll cut it on the CNC down here. Okay, so I'm going to turn my origin. So I'm going to make a sketch on the side wall because I know that the cross section of a 2x4 is based, like I said, 1.5 by, or actually I have to say 3.5 by 1.5 tall in this orientation. And I'm going to go extrude this whatever length I want to make it. Maybe like a little candle holder, like 9 inches. That looks fine to me. I'll make this a new component. I'll save it. I'll rename this thing immediately. Candle holder. Okay, there it is, roughly. I'm going to go make a sketch up on the top of this thing. Flip it sideways. I'm going to draw a circle right in the middle. There's my midpoint on that side. There's my midpoint there. I'm going to go find that. There it is. So these little candles are actually 1.5 inches in diameter, but they have a little plastic casing. And I always think it's good to add a little wiggle room or something like that at least. So I'm going to actually make it 1 5/8. I'm going to add 1 extra 1/8 of an inch. So there it is. And I'm just going to go make 3 of these by doing a pattern. Rectangular. I'll click on this to pattern it. I want to move this direction. Let me see which one that is. It's changing over here. So I'm going to make this actually symmetric. And let me just kind of space that out, whatever I think looks all right. 2.5 is fine. Okay. So that's good. Also, I'm going to make a little, just for decoration, I'm going to make a little chamfer or like a little groove offset here. So let me go do that right now. I'll make a little, let me see here, about -0.5 inch. That looks okay to me. I'm going to make another one. I'll just kind of make it close. In fact, I'll make an 1/8 of an inch difference. If we want to use 1/8 of an inch end mill, we should keep it like that. So I'll just make it a -0.375, which is 3/8. This will be a 1/8 inch gap right there. Okay, and I think I'm going to put a little decoration. I'm going to fillet these. I'm still sketching. Okay, let me end my sketch. I'll extrude these down first. The depth of those candles is 18 millimeters. This will be -18 millimeter, which is like 0.709 inches. Okay, that'll be sitting flush then with the top. And what else here? I want to go make a little fillet, kind of round these edges off. I'll do that. Push that into whatever I think looks cool. That looks good right there. 1 inch, that's fine. Maybe does it look better with more? Maybe actually 1.5. I like that better. Okay. Let me see this sketch again. And I'm wondering maybe I should fillet this sketch right here. So let me go ahead and edit this sketch. And I'll fillet this little groove here. This one, offset. No, not offset. I want to go fillet. This corner, this corner, this corner, this corner. I'll move that in. Also 1.5. I think that's what it was. I hope that goes to be too much. Now let me just do then 1.35. That looks kind of a nice round circle. Enter that. And that other one, I'm going to repeat this fillet and see if I can get this going. Kind of inside of there. I guess I could just offset that one I just made rather than doing this, but that actually will work right there. Okay, that all looks symmetric. Different ways you can do that, but I think it looks fine. Okay, so I'm going to actually go extrude this little thing here. Again, this is not for any kind. This is not for purpose, just for decoration. I'm going to make it go down. I don't know, 0.125, 1/8 of an inch. Okay, how does this look? Okay, and then the last thing I will do is I'm going to put a chamfer on this outside edge and then also each of these. Let me go up and modify, add a chamfer. Oops, not to that. X that out. This and this and this, and I'll do this whole side too. I'm going to make this a 2mm chamfer. Kind of soften those edges. I'm going to add a chamfer, I think, on here. I may do this a little different way. I'm not even sure. I haven't done this a ton, so we will learn together. But anyway, I'll okay this. Okay, I think it looks kind of cool for me. Yeah, I'm good for that. Okay, so let me save this. I'll call this candle holder. This is the second one I made, so I'll call it 2. And I ended up saving it. You should make a little CNC folder if you're in my class. If not, do whatever you want, but this is for my class specifically. And this is it. This is what I want to cut out of redwood. Okay, so how do we do that? So the first thing we do is, let's go into our manufacturing workspace. You're going to see some things up here. It's similar to the design, but we're going to begin from left to right. So the very first thing to do is to make a new setup. So the first thing I do, actually when I do this, I want to make sure I'm working in inches, because that's why I know all the feeds and speeds is inches. I'm going to cancel this. And it almost always comes in as a millimeter, so I kind of need to go through and check, because when I start putting in speeds, I'm like, oh yeah, I'm still in millimeters. So let me go ahead now and make a new setup. The first thing I do, at least, is I go to that stock tab and I don't do any offset. I just change it back to 0. I want to see the true size of whatever my workpiece is. Then go back to your setup, and we got to tell the machine like what orientation are we going to put it down on the table, and where is our origin point, all that kind of information, and also what kind of machine are we going to use. So let's go pick our machine. Our machine here in the wood shop at Torrey Pines has an X and Y axis on the bed or on the table, and a Z on the head. So I'm going to choose this generic 3-axis that has this working on it. It makes you download the model. There might be a different way to not do this, because you got to do it every single time, which is kind of annoying. And we already have it downloaded. I think this is a new update that they did. Okay, let it do its thing. It has to think. It's slow. Extra slow. Okay. So we're going to be using that milling machine. We're going to be milling. And now we want to know what kind of orientation are we going to put this. So I always choose the Z and the X axis. We can choose from that. The Z axis goes up and down. So we're looking at any kind of flat surface like this. That's going to be going up and down from here. So that's good. The Z goes up or down, but the X goes to the left or the right. So I'm going to go click on my X axis and click on anything that's going left or right. So I'm going to click on that. Perfect. Now it's going left or right, but our machine is set up to go the top front, or the front left is the origin. So I want to make this X go off to the right and the Y go backwards. So I'm going to go flip this X axis. And this is what I want. Everything, the X goes from 0 to the right is positive, and going backwards is positive in the Y direction, and going up is positive in the Z direction. This is how you should always get your orientation in this setup for every model, pretty much. Okay, now the orientation's good. Now we got to go place our origin for this workpiece. And if you go select the model box point, that's going to be any of these points on this model box. We're going to be the front left. Okay, perfect. So I'm going to put the piece of wood down on the CNC facing this direction, not like this. I'm going to put it to the side. You could do it like this if you wanted to, but then you'd have to rearrange your orientation and your origin, put it up here. But for me personally, I kind of like this look of it. And make sure the body is selected. Like if there's nothing there, but if you click on there, it'll select your body in blue. Okay. This setup is done for everything we need here. We have our origin, we have our orientation of the axes, we picked our body, we chose the machine, and that's it. Okay. So what you'll see now, it does import that machine, which is nothing like what our CNC looks like. This is like a knee mill or something. So if you click in the white space to make that go away, I wish it wouldn't even show up in the first place, but it does. and we have a setup. If you ever wanted to go back and double check or edit this setup, just double click on it, and you can go back and change anything you need here. As for instance, like the way that you orient this machine, or different ways that where you put the origin. For instance, sometimes you might want to actually put that origin right in the middle, like in the middle of this, if you're doing like a circle or something. So maybe you want to choose it there. That's really useful for circles, but I'm actually going to go back and change this one. Okay, so that's how you can edit if you need to. Okay, now the next thing is to set up our toolpath. So we've done the setup, now we're going to start going into here. If you click on this drop down, you'll see different options. Almost every time we do it, we're going to be doing a 2D pocket. Although 2D adaptive clearing, these are both similar. A pocket is just anything that is not really going to be cutting all the way through. We're just been cutting out a little section, like a little pocket, like your pocket in your pants doesn't go all the way through unless there's a hole in it. So this is not going to be going all the way through. It's like a little section you can put some cutouts within the actual material. So these will be pockets. This all along here, when we cut out this whole outline, is going to be a contour, 2D contour. We can do a chamfer with the chamfer, although honestly, I find it easier just to do another contour along here and then add a chamfer bit. So let's go ahead and begin this. The first thing I'm going to do is make these pockets. Okay, so I'm going to go up here. I'm going to choose 2D pocket. Eventually, we'll explore all of these things, but for now, we're going to start with here. Okay, it needs to know what kind of tool or what kind of end mill are we going to use. If you don't have any end mills already in here, you can go into your local and then add any of these. Almost all of our end mills are going to be a flat end mill. You can type in whatever dimension or size it is. Say we're going to be doing a 1/4 inch. This will just be a label for it. Flat end mill. And then we can go to the cutter. And this is where it wants to give you all the dimensions. It actually should come on the box or the package of their end mill that it comes in. It should give you all this information, but also you can just take a tape measure and measure it. But it's going to be flat end mill. We're doing it in inches. This one I'm going to be using as 2 flutes, and that's the cutting surface. This one, are the ones we have in the shop here have 2 flutes. This will be high strength steel. The diameter, the ones we'll use will be 0.25 1/4 inch, which will also be the diameter of the shaft. And the little arrows will tell you what you're looking at, so you can kind of measure what they tell you to measure. Overall length from the very top, I think ours are 2.5. And then the length below the holder, I usually put about 1 inch up there. This can change depending on how you put that in there, but we'll just say we're putting in 1 inch below. Or sorry, it'll be, if it's 1 inch below, 1 inch in the holder, then it's going to be 1.5 inches sitting below the holder. 2.5 minus 1 inch will be 1.5. The shoulder length, that's going to be actually how much up until, well, there is no shoulder. All of ours are just flat. So I'll just make it also 1.5. And then the flute length from the actual cutting surface that you can cut out in one shot, I think ours are 0.75. So if you need to make it, you can just look down here, or eventually I'll probably add a library you can use. And you can also just go in and actually add a new library. I think if you click on here and add a folder, I ended up doing this. I ended up putting all these end mills that we have in the wood shop into my and I called it TP CNC. So I already have like a couple 1/4 inch end mills by different lengths. Like this one's 4 inches, this one's just 2.5 inches. But you will have to go ahead and start adding in the end mills until I can just share this whole library. Okay, but the common ones are 1/4 inch and 1/8 of an inch, and also the engraving one, which you can look at the engraving one right here. This is for doing our chamfers. We'll do it at, well, you can just see it right here. You can put in your information if you need to see it. If I click on it, I don't want to choose that. But that's how you add end mills. So go back to a 2D pocket. I'm going to go select a 1/4 inch end mill. There it is. I'm going to do no coolant. My speed, I've heard, is 18,000 RPM is a good start. I'll make that the spindle speed ramp. I do the cutting feed rate at 100 inches per minute. Some of the lead in feed rate and the lead out feed rate and the ramp feed rate, I make all 100 inches per minute. We can adjust that on the CNC itself, but that's how I start all this. Everything else I kind of leave alone, and it'll auto fill based on what I put in. Okay, let's go to the next one, the geometry. This is going to ask me, what do I want to cut out? Well, this one I want to cut out this circle and this circle or this circle. It doesn't matter actually, as long as they're the same diameter. It doesn't matter whether you click the top or the bottom, because we're going to end up choosing the heights of all this right here. So I'm going to go look at the side view, and here's how this all works. I'm basing everything off the top of this piece of wood, which we call our stock. So this is going to be our stock top. Everything on here I base on the stock top. So I'm going to go change this to stock top, and I let that clear inside view read this. Let it pause over. It'll kind of tell you what that is. I think maybe in here it gives you, maybe it doesn't. Anyway, I make it go up a half an inch. And then the retract, that's going to be whenever you quit. Actually, there's a picture of it. It kind of gives you all the description of all those. I would pause it right here and read these, okay, and what that actually means. So the retract height, whenever you're done cutting, it's going to also want this to raise up another half an inch. So when it moves around, it's not going to hit the wood. It's going to begin to feed, which means it's going to begin actually going through its motion of cutting the circle. From the stock top, I want to make it go about 2.2 or quarter inch above it. Start feeding it in there. And then the actual real top height is right here, the real true top height with just 0 inches above it. That is the top. And then the contour, or the bottom height, like how deep do I want to cut? I want to cut down to there. So I'm going to go and do a selection. And this is my selection. And I'm not going to add any offset. I want to actually cut down just right to there without any kind of additional or nothing less, actually. If you look at it back here, so the CNC is going to move around at this height. It's also going to begin retracting up to this height. It's going to begin to feed in and start doing its cutting at this green height. The real height of the wood is a blue, and it's going to cut all the way down to this dark blue. Okay, that's how all that is read. Let's go to our passes here. On this one, for cutting wood, it's actually better to do, if you also pause this and read that, but for cutting wood, you can see in the last paragraph there, it usually will cut better with conventional milling, which is right. Okay, if you're doing aluminum, you might want to choose left, but for CNC on wood, we'll choose right, and that's just my standard for wood cutting. Although I do both ways, which means it's going to be doing control and climb cut, or conventional and climb cutting. But I always do it because it does speed up the process. And I don't leave any stock. And multiple depths. Okay, what this means is I don't want to have that end mill come straight down to this 18 millimeter depth and then start cutting all. It's kind of a heavy duty cut. So I'm going to do multiple depths, and the maximum roughing step down, I'm going to just do a maximum of a quarter inch at a time. Okay, so, and that's usually how I do things. I don't do ever one massive cut. I just do a little steps. So I'm going to do it a quarter inch step. Everything else is good. If you actually wanted to go specifically how you chose things, you would preserve the order of the way you clicked them. So I'll do that because I do this one first, and then this one, and then this one. But if you chose like the left, and then the right, and then the middle, if you actually want to do that, you would just preserve the order. If not, it'll just do it whatever way it thinks is most efficient. But I'll preserve it. And then the last one is linking. Okay, the first thing you're going to see here is that there's an error. It's basically saying that safe distance, I'll go over there again. It says safe distance higher than the feed height. Well, the feed height was 0.2. That's from this tab, 0.2. And this is saying the feed, oh, come on. Safe distance is higher. So let's just change this also to 0.2. That way it won't be higher anymore. I don't like to keep the tool down. I let it kind of rise up if we wanted to. I never do a lead in entry or a lead out. I just go plunge right into it and start cutting. If you look at this, you can kind of see, hover over all these ones. It'll kind of tell you what they do. Oh, that's not a very great picture of it. And then the ramping, I don't need to, except this will affect whenever I start plunging the router bit into that first 1/4 inch depth. It's gonna ramp down there. You know, I'll leave it like this just to show you. I'll hit OK. Once this is all done, it's going to calculate the path and what it wants to do, and then you go up here and you can simulate. It'll bring a little start button down here, hit play. This will adjust the speed of how fast, and you can also go backwards, going left. Okay, so let's watch this in slow motion to see what's really happening here. It's spiraling down very tight. It's because we did a 2-degree spiral. Now it's going to cut a 1/4 inch, and then it's going to spiral again down deeper, another 1/4 inch, and then it's going to cut it all out, the rest of it. And it's going to go all the way down until it hits 18 millimeters, which is just under 3/4 of an inch. So this is all good. Everything, the actual blue, that cutting out the big bulk of it looks good to me. I don't think we need to go spiral down so tight. So let's go back and double click this. Oops, double click. Let's go edit that linking where it's going only 2 degrees. Let me change that to, like, say 10 degrees. That should make those little red spirals 10-degree now angle. So it's not going to be so many passes. If you review this again and simulate it, it'll go faster. And that's fine. You don't want to make it too fast. You want to be kind of common sense. This is the blade can handle this. All right. And the more you set up Toolpaths and you kind of cut wood, you'll see what it can handle. But this looks good to me as your first initial cut. I'm going to close this. This one's done. The next thing I want to try out is the chamfers. Let's go do that. So I could do a chamfer, although honestly, I don't really ever do this a whole lot because I always just do a 2D pocket again, or sorry, a 2D contour. And I'm going to go along the contour edges of this. So I'm still going to choose, I'm going to select this now to my engraving or my chamfering bit. In fact, if you choose here again, if you need to add all this, there's all the information that you can get if you need to add this into your library by adding the plus button there. Okay, so I'll select this one. There's no coolant. Again, I'm still doing 18,000. The ramping is 18,000. The cutting feed rate is 100. The lead in and lead out, even though I don't do those, keep them at 100, and I start ramping in at 100 too. That's it. And I plunge a little. Plunging means whenever that end mill goes down, that little tight spiral, I do that a little bit slower. Okay, that's good. Let's go pick out what I want to chamfer. So I want to chamfer basically this outline and this outline and this outline and also this outline. All right, and that's it. Now the depth of it, I want to actually make the chamfer end mill come down to there, and when it comes down to this point, it will end up chamfering that edge. So let me go select these heights. It'll be the same thing. Everything's based off the stock top. So stock top, 1/2 inch. Stock top, retracting out to, or pulling that back out to 1/2 inch. Feeding it in from point 2 from the stock top. The actual real height of it is the stock top right here. But I want to make it come down and touch this line. That's my bottom and nothing extra. Okay, that's good. My passes, kind of the same. I'm going to do right compensation. And I'll do both ways. I'm not going to do any kind of chamfer because it's kind of built into what I'm doing. So it kind of guesses, since we're using a chamfering bit, it kind of guesses, do you want a chamfer? That's why I put that in there. But we're not going to use it because we're doing it kind of manually. And then that's what we're going to change here. And then the linking, I'm not going to allow it to rapidly retract. Actually, no, I do allow this to retract. I don't do any lead in. I don't do any lead out. And there's no ramping on this because I'm not really even cutting that deep. So I'll hit OK. Let's see what happens here. Okay, it made a toolpath here. So let's simulate this. And you can watch what happens. I'll slow it down a little bit. It's going to go down to that depth and start cutting. All right. Perfect. That's what I want to see. That's what I expect to happen. And then it'll move somewhere else and do this. Oh, it's going to that one. I can speed up a little bit, but you never want to skip this. Okay, see, this might be an instance where you might want to do preserve the order, because now it chose to do this one first. That's okay with me, but if I really want to do these first, I would preserve that order, and that will be it. Okay, so that looks good to me too. So far, so good. I want to go check this out though right here. So I'm going to go do another 2D contour. I'm going to do all the same. I actually kind of remembered it all. Yeah, everything is still good here. Okay. Still using a chamfer bit. The geometry I want to do is I got to either pick, maybe I could have made this less, but I want to choose one of these outlines, either this one or this one. I probably should have made it in the middle somehow, because it's going to make that point of the chamfer come down. I want to kind of go in between there, but I can't now. So let me just look at which one I want to choose, which one I think looks better. I'm going to do the inside line. Okay, so I'll just choose that. That'll be my path that it takes. That's all I need to do. The height's the same thing as before. Keep on, it all kind of repeating itself. You should get to know this pretty quickly. And then the selection, I want to make that come down to here. Or I chose the inside one. Well, actually, it doesn't matter. The depth I want to come down to is there. Okay. And I'll go through my passes. I'm going to go to the right. Don't need to do the chamfer because I'm building it in manually. And the linking, no lead in, no lead out. Good. Let's see what it does here. All right, I'll simulate this. It's going to go in there. Oops, it's a weird tilt. That's going. How deep is that looking? Yeah, it's a pretty good chamfer there. It's going pretty deep. 1/8 of an inch. That might be too deep. Okay, so here's how you can change this without actually changing the CAD model. Go back and double click on this. Go back to your heights. I want to make this I want to go down to that 8. I made this an 1/8 of an inch deep, but maybe I don't want to go that deep. I'm going to maybe add on an extra 1/16. So 1/16, and that should move it up a little bit extra. Okay. So it won't go actually all the way down to what I chose. It'll go down to what I chose, plus it'll go up. Then I'll go up an extra half or 18th or 16th of an inch. Because I'm not looking for a massive chamfer in there. That looks a little bit better, I think. I don't want it too deep. My orbiting is weird here. Okay, but it'll make that groove, which I think looks kind of nice. That's good for me. That's good. Okay. The final thing to do here is just cut this whole thing out. All right. Keep in mind though that when we cut this whole little piece out of here, the whole 2x4 that we have, it's going to be, this whole little candle holder was going to be sitting loose within that piece of wood. So how are we going to secure this? So the answer to that is we need to screw this wood in to the CNC bed. So even though I said this is going to be 9 inches across, I'm really going to take a piece of wood that's maybe like, I don't know, like 11 inches or like 12 inches. So I have a little bit of extra wiggle room over here to screw in the wood, and over here a little bit extra screw in the wood. And then when it's all done, it's going to end up cutting this. So let's actually go back and cut this whole contour out. This will be another step, and this is going to be a contour that outlines the whole piece. And I'm going to go back and choose a 1/4 inch end mill. Now you got to make sure this piece of wood is 1.5 inches deep, and the length below the holder is only 1.5 inches deep. So we're going to be getting pretty close to the collet, which is what holds the end mill. You just got to keep that in mind. If you are trying to cut something that's deeper than whatever you have coming out below the collet of the CNC, you're going to end up crashing the end mill or crashing the CNC. It's going to run into the wood. The actual motor will. So we have to kind of keep an eye on this. You can always check it whenever you put the end mill into the CNC. And if that was going to be an issue, you would have to go out and buy a bigger or longer end mill. That's why I bought this 4-inch long end mill, just for that reason. I wanted to cut something that was like 2 inches or 2.5 inches deep, and I only have a 2.5 inch end mill, so I couldn't cut 2.5 inches because you also have to have the collet holding the tool, so you have to buy longer ones. But I think in this case, this one will work. And if it's not, then we'll change that tool. All right, no flooding. Same thing as before. Ramping is 100. Okay, no flooding. The geometry is going to be this outline or this outline. Doesn't matter. I'll just choose the bottom. And now here's the thing. Once this thing gets cut out, this little piece is going to be loose. It is now cut from the original piece of wood. That's dangerous because now you have a big piece of wood here floating around with nothing actually holding it to the table. And I don't really feel like screwing in through this wood with a screw to secure it. So there is because it'll make it look ugly. So here's the trick for that. Whenever you're cutting a contour, and you don't want to drill through your product, put a tab on there. That's going to connect and add some tabs to the workpiece that you're cutting it from. Now these ones aren't really going to help because the actual workpiece itself is only 3.5 to start with. So actually this is going to be the very edge of the wood. But we can have a couple tabs here, which will hold that piece. And so I'm going to go make this, the tab height kind of high up. So I'm going to make it say 0.5. Okay. These ones aren't going to be even affected because the wood isn't that wide, but these ones will be because I'm going to make the wood, the piece I'm going to put on the CNC will be longer than this. So these ones will be still connected to the other piece. Now this piece will be not loose in there, it will be connected. And by the way, this the length of this begins at that bottom feed height, which I'm going to set up right now. So let's go ahead and do this. My retract height is from the stock top, 1/2 inch, and I'll go through and do the same thing. It's always kind of the same, except for the bottom height is what changes usually. Okay, so the bottom, I want to go select the bottom of it. That's how deep I want to go. But if you think about this, if I only go down that deep, if there's any kind of variation in the thickness, it might not actually cut all the way through. Maybe it'll be a little bit slightly less than you have, and then it's not really cut. I actually want to make that end mill go down below here a little bit extra. I do an extra -1 millimeter under. That'll cut into the spoil board of the CNC, and make sure you cut all the way through here, except for the tabs will still be coming up beginning from this bottom height. It'll be a 1/2 inch above there. Okay, so you'll see whenever I set this thing all up what those tabs are used for. I'm going to do right compensation, my multiple depths. I can't cut this all in one shot. I'm still going to do 1/4 inch steps. In the linking, it's going to tell me the same thing. My feed height is 0.2, so I'll also make this 0.2. And no lead in, no lead out. Ramping, don't need to because it's already set to a 1/4 inch max. Okay, so there you can see what's going to happen. It's going to make a bunch of passes around here. It's going to stay connected through these little connections right here. That's what's going to hold it to the rest of the workpiece. This doesn't fly off. Let's simulate this and see what happens. It's going to go down 1/4 inch. Start cutting around the contour. And then this other side is going to go down again, 1/4 inch. There it goes. And that's how it's going to go all the way through. And at the very end, you can see here, I'll go back a little bit. What those tabs, so it's going to change the Z height when it's wrapping around here. Probably on this one right here. Slow this down a little bit. See how it goes up? It's going to not cut that part. That way it'll connect it, still connected to the piece of stock that I put in there. Okay. And it's going to go all the way down until it cuts underneath the wood. So it's still doing more. And right here, now it's cutting underneath, which is be a full cut. Perfect. And then it's done. Okay, actually this looks ready to go. This is everything I need. The only thing now you want to figure out is what's going to minimize your tool changes. I'm going from a 1/4 inch flat end mill to a chamfer to a chamfer to a 1/4 inch flat end mill. That's going to be a tool change from the flat to the chamfer, then a tool change from the chamfer to the flat. So why don't we just do this? Why don't we take these two chamfer bits and do that first? All right, which means that whenever you do it, and we can do these together, even though there's two different operations, we can actually do them together. If you just hold shift and then select both, they'll group together, and we can simulate this. So it's going to be cutting like this now first into our fresh piece of wood. This is okay. And then chamfer that one. And now it's going to do this chamfer, which is a different operation, but because it's different depth, but they're both the same bits, so I might as well do them at the same time. Do that first. And then we can do the pocket and then the contour also in one shot combined. This will be one tool change. So let's go simulate these two. Cut all that out. It's already been chamfered. Okay. And then I'll go ahead and do the final contouring. All right, so you can begin grouping your tool paths. And this looks good to me. Okay, so the final step to send this thing to the CNC is to, well, first let's save it. Did a lot of work there. And this is all good to go. So we have to go now. I'm going to do these first two. This one and this one I'm going to do first with my chamfer bit. So I'm going to go ahead and post this. That's what you call it. You post it. It generates machine code. You can read that right there. That brings it into reality. We will post this process. The first thing you have to look at least on my Fusion, is it's calling it just a simulation. Well, we're doing a real thing. So click on that, and if you go up here to Mach 4, that's what we use, the software we use, the Mach 4, and that's what it's going to be opened up for. And you can put this wherever you want to. I'm going to save it onto, this will actually be saved into here. I'll just post this. It gives me the option actually afterwards to save it onto my desktop. I'm going to call this candle holder 1 space 1/4 inch, because I want to label, if I ever give this to somebody else, I want to label what end mill I'm giving. So I can even call it a flat end mill, 1/4 inch. Save that. Probably because I'll just call it flat. I know that's going to be a flat 1/4 inch. All right, save that. Oh, sorry. Actually, you know what? That's not it's a chamfer. Let me actually go ahead and do that again, because I don't want to get confused when I actually run this. It's going to be Mach 4, post it, calling it's candle holder chamfer, actually. Okay, so that'll be the correct one. This will pop up. It'll bring up all the G code actually of every single location it does. Close that out. I'm going to post these also right now. The actual flat end mills, I'll post them. Change this to Mach 4. I'll post it. I'll give it a name in the desktop. If you guys are doing this up in the CAD lab, you're not going to put it on the desktop. You're going to put it onto a USB. Then you can bring the USB down into here, and then you'll have the files ready to go into Mach 4. So that's an important thing I should say from the beginning. We need to run the machine, the computer is down here, not up in the CAD lab. So save that file to a USB, or borrow USB or something where you can, or then email the file to yourself and you can open it up down here. But you don't want to open up on desktop because that desktop is not in the wood shop. Okay, let me call this candle holder flat. I already called it that one. I can call it that one again. I want to replace it. Make sure it sets this up. Okay. Sometimes it doesn't do that. It'll give you an error, so I have to change the name, but this one seems to work. Okay. This is done as far as posting it. Now, what do we do? The next step is this. So you turn on the CNC. I'll show you a video of that. I'm going to turn it on. Maybe you can hear that. And then you open up Avid CNC Mach 4. I don't know if you guys have this or not up on your computers. I don't think you do, actually, which is an issue. I don't know. We'll check. If not, you have to do it down here. Okay, and now we're at the CNC control. So I'm going to start taking some video here from this point. Okay, so I'm going to stop this screen.